Hello everyone, this is Homework 30, Part 2. We left off with reducing rational expressions, or simplifying rational expressions, where the general procedure once again is to factor the numerator and denominators completely, and then divide out the common factors. And you can use different terminology for that. So we saw one example with the greatest common factor in both numerator and denominator, and then another one where the denominator factored as the difference between two perfect squares. So on the next page we finish up with 4 more examples, and we see in question 3 that the numerator is just a binomial, so that's going to have to stay as it is, as x minus 5, but the denominator is a quadratic trinomial, which we anticipate will be factorable into the product of 2 binomials. And the nice thing about this is the leading coefficient is 1, so we know we just need an x and an x. And then if you want to list the factors of the constant term, negative 45. Okay, 1 and negative 45, that's doubtful, but negative 1 and 45. Let's see, 2 doesn't divide, 3 doesn't go, yes it does, 3 goes in evenly 15 times. So 3, negative 15, negative 3, and 15. But those are no good, because again we're looking for the 2 factors to combine to give a negative 4. So then let's see, the next pair would be 4 doesn't divide into 45, 5 does. 5 and 13, so 5 and 9, excuse me. So 5 and negative 9, and I think we got it, right? But let's just be complete, negative 5 and 9. And that's all the factors, 45, and the pair that combines to give a negative 4 is 5 and negative 9. So we have an x plus 5 and an x minus 9. So in this example, it was designed so that there is no cancellations. So therefore, that would be our simplest form, and we'd have to write it in that factored form. Okay. Typically, what's going to happen, though, and it's almost tempting in this case to see that this probably could have been a plus 5 so that we get a cancellation. But this example just shows us that sometimes you end up with situations where you don't get cancellations. So in example 4, now we have, it's basically instead of 1 factoring problem, 2 factoring problems, right? So in the numerator, an x and an x. Okay, I'll list the factors of positive 10, and that would be 1 and 10, of course, negative 1, negative 10, 2 and 5, negative 2, negative 5, and that's it. So then the pair that it adds or combines to give us the positive 7 is the 2 and the 5. Both positive, so x plus 2, x plus 5, doesn't matter what order. Could have wrote x plus 5, x plus 2. And then for the second problem, or for the denominator that is, we're going to list factors of negative 10, and that would be a negative 1 and a 10, a 1 and a negative 10, negative 2, 5, 2 and negative 5, and that's it. And then the pair that combines to give us the negative 3 is the positive 2 and the negative 5. So again, could have set this up, product of two binomials, x and x again, and a positive 2 and a negative 5. And then we could notice, and typically this is what's going to happen, that the numerator and denominator do have a common factor. The x plus 2's, cancel them out, replace them by 1's. And 1 times anything is itself, so we just have x plus 5 over x minus 5, and that's as far as we can go. Alright, so then a few more examples. In the numerator here, we should recognize that as the difference between two perfect squares. So again, there's no linear term. These kind of jump out at you because you have a squared term and a constant term. It's always going to be a difference, and those two will be an x squared and a number that's a perfect square. So x and x, 2 and 2, 1 negative, 1 positive, doesn't matter which. And now we factor the denominator, and we'll need an x and an x. Okay, now if you want to use the factor method, or hopefully you become proficient at this, where you kind of think in your mind, you know, you got to get 4 and combine to give negative 4. So you might say to yourself negative 2 and negative 2 right away. But if not, if you list the factors, 1 and 4, negative 1, negative 4, 2 and 2, negative 2, and that's all the factors. And then the pair that combines to give us the negative 4 is the negative 2 and the negative 2. Okay, and then once again we see cancellation. The x minus 2's now cancel, replaced by 1's, and then we're just left with x plus 2 over x minus 2. And that's as far as we can go. Alright, and in number 6, okay, the x minus 3 that's in the denominator, we're just going to recopy that because that's a binomial in and of itself, and there's nothing in common, so just have to rewrite it, maybe put parentheses around it if you want to identify the fact that it's a binomial. And hopefully you recognize the difference between squares here. It's in the opposite order that we typically see it, because we typically see, like we did in here, x squared minus, 4 or 9 or 25 are the common ones, right? But here it's reversed, but that's okay. What happens then, instead of having an x and an x in the first position, the x's are in the last position. And we'll need a 3 and a 3 to get 9, and then 1 negative and 1 positive. But here, when we compare numerators and denominators, hopefully we recognize that 3 minus x and x minus 3 are opposites. And so we'll cancel one factor, typically the denominator, and replace it by a 1, and then cancel the factor in the numerator and replace it by a negative 1. And so we have a 1 in the denominator, so no need to write that. But this negative 1 has to be written out in front of a set of parentheses that contains the binomial 3 plus x. So you could write it with the literally the negative 1 there, or the 1 is understood, so you could actually write it as a negative, and then in parentheses 3 plus x. But we don't want to distribute the negative because we want it in factored form, and so that is the preferred answer. Okay, and then I kind of just left some space because there's other examples we need to show you that should take care of all the situations that you'll encounter in your homework. And so that's the end of part 2 of homework 30. So we'll see you when you're ready for homework 31.